Hello students, we are back with the exercise 1C. So far in all the previous sums and videos we have finished slab 1. Okay, so slab 1 completely done everything. So I hope you'll be practicing those sums again and again to memorize them and to understand them nicely so that you're able to do by yourself all the sums. Now we'll go to slab 2 of this exercise 1C. Okay, so today we begin with slab 2. Here's slab 2, short answer type questions, slab 2. So we'll do question number 9. Let us read question number 9 first. Question number 9 goes like this. See, find the smallest number which when divided by these three given numbers, there's 35, 56, 91. Find the smallest number which when divided by 35, 56, 91 leaves remainder 7 in each case. Leaves remainder 7 in each case. Let me just quickly say what the question is asking you to find. The question here clearly is telling you find the smallest number. Means you define the smallest number. What is that smallest number? We don't know. But they're asking you that find that smallest number which when divided by, that means this smallest number which I've written as question mark, when this smallest number is divided by, means what? It's acting like dividend, and this is divided by, here 35 is acting like divisor. Find the smallest number which when divided by 35 or n by 56, and also the smallest number when divided by 91. Okay, so see, that means this 35, 56, 91 are all like divisors here, okay, for this particular question. So find the smallest number, and this smallest number is same. I've given 3 question mark, doesn't mean that there's 3 numbers, okay? They're the same number. This is the same particular number, one particular number. Find one particular number, unknown number, which is at present. That should be smallest. There should be no other number smaller than this, okay? Find the smallest number which when divided by 35, the 35 is the divisor, f is the divisor, and 91 is the divisor. The same required number which is unknown at present. When you divide this number by this 35, it's 91, it leaves remainder 7 in this case. Means what? When you divide this required number which they have asked to find by 35, remainder should be 7. And this also, when you divide the same number by 56, then the second number here also remainder should be 7, and the same number when divided by the third divisor 91, remainder should be 7. Okay, first of all, it's clear from here that that smallest number is not completely divisible by 35, 56, 91 because remainder is not 0. Okay, remainder comes 7. Now think logically. It means that whatever is the required number which we don't know, that number is not completely divisible by 35, 56, and 91 because they leave remainder 7 in each case. So if you think very nicely, from that required number, that smallest number, from that required smallest number, if you subtract these 7, because 7 is the remainder, if you subtract 7 from that required number, say that new number comes has to be, say, x. Try to understand. From that required number which you are finding, the smallest number, if you subtract the 7 beforehand, before you divide, you subtract 7 already from there because 7 was remaining. So if you subtract the 7 already from this number and say the difference comes x, now this x, this new x, now when you divide by the same 35, this new number x, which is 7 less than the required number, if you divide by now again 56 and the same x, which is the difference of the required number, and 7 by 91, in this case, can you tell me can you just guess, students, what will be the remainder here? Because 7 was remaining, 7 was the remainder before from this number, but I already removed 7. Okay, that means what? If I already removed 7, means what? Now 7 will be no more remainder here. Now the remainder will be 0. Okay, because from this number, because x is the number which is 7 less than the required number. So since 7 was coming in all this case, so in all this case remainder will be 0. That means what? In simple word, that required number means this new number is now completely divisible by 35 by 56 and 91, completely divisible. And moreover, see, x still the smallest number. It's not the required number, because required number is this number. This is the required number. But even though x is not the required number, but at least we know that x is the smallest number which is completely divisible by 35, 56 and 91. Okay, since that means what, x comes in table of 35, x comes in table of 56, and x comes in table of 91. So it means x is the multiple because it comes in table. Moreover, it's same, so it's common, same number x. Moreover, x is the smallest number by which you can divide, which is divisible by 35, 56 and 91. That means what, these are all lowest, because the x here still in this question we start with the smallest number question mark, then from that question mark number we'll subtract 7. So means what, still the smallest number. So means what, LCM we have found, means we have got here term called LCM. That means what, you have to find now LCM of 35, 56 and 91. That LCM is your x. Understood? Because lowest common multiple, it should be smallest number, it should be same, and it should be multiple. Multiple means what, it should be, this x should come in the table of 35 also, 56 also, 91 also, so it should be multiple. Lowest common multiple, LCM. So means what, so see the working plan. If you find LCM of 35, 56 and 91, you'll get a number x. X not the required number. Now to find the required number, say this question mark from here, to find the required number in this x, say this minus 7, if you take this side, minus 7 if you take from left side to right side, become plus 7. That means the required number will be what, whatever LCM you'll get of these three numbers, 35, 56, 91, LCM x, in that number if you add 7, then this will give you the required smallest number. Okay, so there's a working plan. That means to find the required smallest number in this question number 9, see, let me just quickly tell you what should we do. To find the smallest number in this question number 9, as per the question, the working plan, the strategy here or the procedure here is what, first find the LCM of 35, 56, 91. Okay, first find the LCM of 35, 56, 91, and after finding the LCM of these three numbers, in that LCM value you add 7, because 7 is remaining. I've explained you nicely here all these things, okay, how it came. So in that LCM of this 35, 56, 91, you just add 7, and that will give you the required smallest number. Okay, clear? So this is the whole idea, okay, of doing the sum. So we can start. So let's start the sum then, students. So since I've explained you the theory, I've explained you the procedure, so let me straight away start the solution. Here the three given numbers, 35, 56 and 91. Okay, now see, since the smallest number when divided by these three numbers, 35, 56 and 91, leaves remainder 7 in each case, which I've done. See here, smallest number is this one. Since this smallest number when divided by 35, 56, 91 leaves remainder 7 in each case, so the required smallest number is nothing but, it is equal to what, therefore the required smallest number will be what, see, see, from the in the LCM of 35, 50, 56 and 91, we have to add plus 7. Therefore the required number is what, in the LCM of these three numbers we have to add 7. Okay, Clear? So now we'll find the LCM. Now to find the LCM of 35, 56 and 91. Okay, so now to find the LCM of this one, we have to do prime factorization method. So let's do prime factorization method now. So we'll do prime factorization 35, 56 and 91. Okay, so let's do, to do prime factorization of 35, 56, 91, so we have to divide same way. The first we should try by the first prime number 2. Okay, prime factor 2, prime number 2. But can you divide 35 by 2? We know that 5 is an odd number. Okay, 1, 3, 5, 7, 9. So odd number can divide by 2. Then we should try by 3. To try by 3, the test is what? You have to add this to 3 plus 5, 8. Think this and tell me, like, and tell to yourself that, ask to yourself, does it comes in the table of 35? See, sorry, in the table of 3. 3 plus 5, 8. And in the table of 3, 8 doesn't come. 3 1 is 3, 2 is 6, 3 is 9. So 8 doesn't come, so we cannot divide by 3 also. You cannot divide by 2 because it's odd number. You cannot divide by 3 because the sum is not a multiple of 3. So since 2 and 3 cannot divide, so the next prime is 5. And can you divide 35 by 5? Yes, because to be able to divide by 5, the unit digit should be 0 or 5. So yes, we can divide by 5. 5 sevens are 35. And you see, students, now 7 coming. 5 sevens are 35, 7. And we all know that 2, 3, 5, 7. The 7 is a prime number. And prime number we divide by itself. 7 ones are 7. Okay. So we have done prime factorization of 35. Okay. So now we'll do prime factorization of 56. As you know, see, the unit digit is what? 6. 0, 2, 4, 6, 8 are all even number. Okay. When the unit digit is this one. So 56 is 6 is even. So we can divide by 2. 2 ones are 2, 2 twos are 4, 2 threes are 6 pigs, so 2 twos are 4. 5 minus 4, 1, 1 in 6, 16, 2 eights are 16. Okay. Then here again 8 even numbers, so 2 ones are 2, 2 fours are 8, 4 is even numbers, so 2 sevens are 14, and 7 is a prime number, 7 ones are 7. Okay. Clear? Now 91. To do prime factorization 91, again same rule. First we should try by first prime number 2, but you know that 1 is an odd number. 1, 3, 5, 7, 9, odd number. The 91 is an odd number. The odd number we cannot divide by 2. So the first prime number 2 we cannot divide. Then comes 3. Can you divide by 3? For 3, same rule, you have to add, and the total should be multiple of 3. 9 plus 1, 10. In the table of 3, 10 doesn't come, or 10 is not a multiple of 3, because see, total is 10. 10. 3 1 is 3, 3 6, 3 is 9, 3 4 is 12. 3 3 is 9, 3 4 is 12. 10 doesn't come. So you cannot divide by 3. 2 and 3 gone. Now whose turn? 5. By 5 we cannot divide, because to be able to divide by 5, the unit digit should be 0 or 5. It's 1. It's neither 0, it's neither 5 nor 5. So we cannot divide by 5. 2, 3, 5. The next prime number is 7. Now to be able to divide by 7, for 7 there's no test, we have to divide on that off. So 91 we divide by 7. Okay, next one is 7. 7 ones are 7. 27 3s are 21. That means divisible. See, remainder comes 0. Okay, when you divide by 7. Okay, so 7 13s are 91. Okay, when 7 is 7, 9 is 7 2, 2 and 1 21, 7 3 is 21. Then you know the list of prime number, students. In the list of prime numbers, students, if you see the list of prime numbers, we have just now divided by 7. But if you see that 13 is a prime number itself. So the moment prime number comes, divide by itself. 13 ones are 30. So we have done prime factorization of all these numbers. Okay. So now we'll write prime factorization of 35, which is equal to 5 into 7. See, and only one times power 1. Now we'll write prime factorization of 56. So 56 we got 2 into 2 into 2 into 7, which gives us 2 3 times, so 2 cube into 7 only 1 time, 7 power 1. Okay, clear? So this to prime factorization. Now we'll write prime factorization of 91. So we got 7 into 13. 7 1 time and 13 1 time only. Okay, so we have done prime factorization. But in this question, we are not asked to find HCF. No need to find HCF. Okay, we also means what in this question we do something with LCM. I've already told you, explain you that LCM means lowest common multiple, and the number that you are finding that will help us to find that number must be the LCM of 35, 56, and 91. Okay, clear? So that's how we find LCM. So let's find LCM. So therefore, LCM of 35, 56, and 91. So I hope you remember the definition of LCM. What is LCM? LCM is the product of all the prime factors, whatever prime factors we have, with the highest power. So let's write all the prime numbers here that you find. So you can find that the prime numbers are here 5, 7, 2, and 13. So we have 2. You can write 2 first also, no problem. Then we have 5. Then we have 7, and then we have 13. These are all prime numbers. See, 5, 7, 2, 2, 7, and 7, 13. Write only once, don't repeat. Now write the highest power. See, when you write about 2, then see the prime factor 2. 2 cube. There's no 2, but there's, see, in 56 there's 2. And 2 has power 3. The power 3 is already the highest, okay? It's the only power and it's the highest here. 5. When you see for 5 also, see, 5 is present only in prime factor 35. 5 is not present here. The 5 is power 1, so there's already highest, okay, for this particular question. 7. Now 7 is coming in all the 3 prime factors. See, 7 power 1, 7 power 1, 7. 7 is common, okay, no problem. But see the power, highest power is only 1. More than 1 we don't have. And 13 also coming only 1 time, and 13 has already power 1, okay. So now we'll multiply on this. Okay, so all the prime factors are there with the highest power. Now 2 cube. 2 cube means what? 2 into 2, 4, 4 into 8. It's not 2 into 6, okay? Do not make mistakes. 2 cube means 2, 2, 2, 3 times 8. 5 power 1 means 5 only 1 time. 7 power 1 means 7 only 1 time. And 13 power 1 means 13 1 time. Now we'll multiply all. After multiplying, we'll write the value here, okay?